Welcome to another MeteorJS tutorial, this time on reactive data structures. And I want to show you how to write your own reactive data structure, in particular, how to write a reactive stack. And that's nothing more than a reactive version of the classic stack implementation. And if you forgot what a stack is, this is basically an abstract data type that has this last in, first out principle of items being pushed onto the stack and then being popped off the stack for access. That's basically it. It's not very complex, and this is why I love it as an example to show you how to create your own reactive data structure. So let's get started. By the way, if you still don't understand what a stack is, I will link a resource in the description, but you will also see how it works after this tutorial. So hopefully you will also get a better understanding of stack if this is still new for you. So have Meteor installed and then create a new Meteor project using Meteor create. And then it's asking you about the project name. I will call this reactive data structure as acronym RDS. And then I'll choose Blaze as my front end technology. Of course, you're free to choose whatever you like. You could also use React or Vue.js or Solid or Svelte or whatever you want, but I'm sticking with Blaze because it integrates best with Meteor, and this is what I still like the most, as it has this old school Meteor style as I know from back then. So let's go into the project and then run Meteor as a command in order to start the project. It's now building the packages, of course, and while it's building, let me quickly show you the structure. This time we only want to work on the client side because there is nothing related to the server yet involved. And of course, there might be chances to use reactive data on the server, but for now we only stick to the client, and this is why we work in the client folder and only work on main HTML and main.js. So while I talked about that, our website has loaded, and as you can see, this is the default boilerplate that has been loaded. And then I'm going to remove all these defaults here because we don't need that for our tutorial. Just remove them. Also remove the title and rename it something like reactive data structures. And then also open the main.js file. And there you can also remove all these boilerplate templates. We don't need them for now. Okay, if you save that, then Meteor will automatically reload, and then you can see in this that this is now our updated view. There is only this title, reactive data structures, and nothing else. And that's okay for now, because before we go into any visualization of the stack, we first have to implement a stack. And this is pretty easy. Simply go into client.js, create a new file, and call it ReactiveStack. And then let's export a class named ReactiveStack. And in the constructor of our ReactiveStack, we instantiate some items. That's the underlying data structure. So that's an array, basically. And to the outside for our stack, we implement only some functions like push. So with this, we're pushing a new item to the items. Unfortunately, the JavaScript arrays already have a push functionality for us implemented. That's pretty nice. And we just return the new size, items.length. That's it. And then we have another operation called pop. And for pop, we simply return, sorry, I just forgot, it's this.items, of course. And for the pop operation, we return this.items.pop, because what it does is it pops the item as with the stack and returns it. And this is what we do with pop. We remove it from the stack and return it also. But there's also another function that's called peek. And with peek, we want to return the topmost item, but we don't want to pop it from the stack. And this is something like items at -1. There we get the most top item from the stack. If you never heard of this items.add function, by the way, this is a more recent addition to the JavaScript standard, and you can read it up, for example, on MDN. I will link the resource in the description, and it's pretty comfortable to use this instead of items.length -1 and so on. Okay, and then maybe we want to have one more thing, and that's called size. And I will show you later on why this is, why we use another function instead of directly accessing the items.length. Okay, with this, we have already created a basic stack structure. It's a minimal stack structure, but because we want to visualize the stack, we also need to implement a all function that simply returns a copy of all the items in the stack. And this is return an array.concat this.items, because this is basically a copy, a shallow copy of the items. So the items themselves are not copied, but the overall array is copied. So you don't manipulate this stack's underlying array. That's fine so far, but it doesn't preserve the stack order. So we will have to reverse it later on, because otherwise, if we iterate this, it will show actually the first one as the first and not the last one. But as we learned at the beginning of this video, this is a last in, first out data structure. Okay, this is a non-reactive stack, but let's integrate this into our template now to make it reactive. First of all, create a template.stack.onCreated. That's the function for our new template. And then every template in Blaze has an instance, and there we can instantiate a new stack. New reactive stack. That's the stack of our template. And then we want to have some helpers. For example, template.stack.helpers all. Or let's call it items. That's maybe even better. And then we say return template.instance.stack.all. So with this helper, we allow the template to iterate over all entries. Usually you don't use that in a stack because you don't give access to the underlying data structure. But here we want to have it because we want to visualize it. So I'm adding this only for you to get a better understanding. But as I said, to visualize the stack in the correct way, we need to reverse the order. So we call toReversed. That's, by the way, the non-mutating version of the array reverse function, but it's not mutating the actual array, but returns a new array. So I suggest you to use this instead of array.reverse. Okay, and then we want to have also the topmost item. And in order to get the topmost item, we return the same stack, but with the peak function, because that's not mutating the stack, but allows us to read the top item. Okay, and then we also need some events to push to the stack or pop from the stack. And we will implement some buttons. So I will have some events on click dot, I will call it push btn, and there will be an event called pop btn. And I know this sounds a little bit abstract here, but let's move over to the actual template. So let me split this and in parallel write the actual template here. Okay, so the stack template I mentioned here is basically this one. And there are two functions here. First of all, we have this items and the top function. And we have the user input. So let me start with the user inputs this time, because if the stack grows, then it would move the user inputs. So put them on top so they never move on the screen. First of all, there is a classic HTML input of type text. This is where we want to enter any item there. And then we have a button with the class push btn. Or push, this is where we want to invoke the push with the content of the input. And that's actually what I'm listening here in the template.stack.events. And then we also want to have a pop btn, and this is to pop from the stack. And then we want to peek into the top, so we say top and then top. That's always showing the topmost item of the stack. And this is basically the result from this function. Okay, and then we want to visualize the whole stack, just for you to understand. And then it's an unordered list, and we want to iterate all stack items. So we use an hash each item in items, and items is this function here. And then you write a list item with the item content there, and we close the each. Okay, looks good so far. We of course also have to include the template into the body so that it's actually loaded. But let me reload in the meantime. But there is still something required here that's not full of it. So that's how it looks like. Then this is the input. There's some push, some pop, and the top. But as you see, there's nothing happening because we haven't implemented anything here. So let's quickly implement this. First of all, prevent default the event because we don't want to send any forms, but we need the instance. And this instance here, this is always passed to the events. That's the same instance as in this uncreated block. And here we want to first of all get the item, and we say instance $, and then we need a class name for the input to get the item actually, and it's like item. Okay, and then we need this .item here. So this is basically, like you know from the past, this ancient jQuery accessor. You could also write a document query selector, but you use this in place favorably because it scopes only templates, so it will not look up the whole document object model, but only scope to this template. So it's blazingly fast. So you got this item, and then you want to push this item to the stack. Instance.stack.push item. Okay, and then let's do a console.debug of the instance.stack all. Then let's run this just to see what happens if we push onto the stack. And you see, there it is. But as you can see also, it's pushed onto the stack. It's pushed onto the stack, but it's not in the list. So therefore, we now need to make the stack reactive. In order to do that, we get back to our stack implementation here, the ReactiveStack. And in order to make it reactive, we only have to focus on what Tracker, that's Meteor's reactivity system, provides for us. Tracker is fairly complex, and it can offer a lot of things to make very complex scenarios possible. But for our scenario, we really only need one thing, and that's tracker.dependency. This dependency class is basically something like an invoker to any observers to your data structure. And with this, you tell any observer, like an auto run, for example, that, hey, there is some data change. Please rerun this computation and get the new result. So we import tracker and create a new tracker dependency on this data structure. This step, short for dependency, is a new tracker.dependency. And if we have a writing operation where we want to inform observers that something has changed in the data, we have changed things in the data, then we call this .dap.changed. That's the function, and we call this on the push, because on push we changed the underlying data structure, and on pop we changed the underlying data structure. So this is what we call there. And for the read operation, we want to ask if the tracker is actually active. So if tracker.active, that means if we are in a running computation, then we want to call this.dep.depend. And with this, we can simply add this to size and to all, to any read operation. And this already makes it reactive. So of course, there is a lot of hidden complexity we haven't shown in this tutorial yet, but this is also just an entry series, okay? So let's save this and let's see how it looks like when I'm pushing to the stack. And as you can see, there is now object. And why is that? Because I haven't read the value. I just have read the item here. And this item is currently the input object. So we also need the value. And this is item.val. That's the function to get the value. And we also want to clear the input. So we after that call item val null, and then it's working. So we add something to the top, it's foo, and then the next one is bar. And as you can see now, because we reverse the order, the topmost item is always on the top of this stack list, and then it's move. And as you can see there, so one thing left, it's the pop functionality, but this should be the simplest of all. Maybe you already know how to implement it. You basically run instance.stack.pop. Let's reload this page. Let it automatically reload. So we add something to the stack. And then we use pop to remove it from the stack. And as you can see, this top always refers to what we peek from the topmost item. And that's basically it. Congratulations, you have implemented a reactive stack, which you can use in any of your MeteorJS frontend, maybe React, Vue, Svelte, Solid, or Blaze. And I hope you liked the video. Please leave a like, subscribe for more of these types of videos. Keep looking into the description because we will constantly update links there and resources. And of course, wait and look for our upcoming tutorials on reactive data structures. There will be many more, like queues, lists, linked lists, trees, whatever you can imagine. We will go through many of them. And with that, I wish you all the best and have fun. Happy coding.